In this video, I'm going to show you how to graph square root equations and square root inequalities. So we learned recently that denominators are not allowed to be zero. So that was a domain restriction, and now we're learning a new domain restriction, and this one is that the radicand, which is the thing under the radical, is not allowed to be negative. So that is, it has to be greater than or equal to 0. So for this example, we see x under the radical. So whatever is under the radical has to be greater than or equal to 0. Alright, the range is going to be y is greater than or equal to 0. I'll show you how to figure that one out later. Alright, so to graph these, you're going to make a table, and you want to plug in numbers that are perfect squares. So you're not just going to go 0, 1, 2, 3, because it's going to be hard to take the square root of 2 and the square root of 3. So if we plug in 0 for this x, if we plug in 0, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of negative 1 is I, but we're not going to graph that because our graph is only for real numbers. Alright, so when you graph these 0, 0, 1, 1, when you graph these points, you'll see that it makes a sideways parabola, but only the top half. 9, 3 doesn't fit. So it's like a sideways parabola, but only half of it. Notice that the arrow over here is still rising very gradually. So even though it's gradual, it's still rising. So the range is every y value greater than 0, greater than or equal to 0. So it starts at 0, and then it's slowly going to keep rising. So the range is every y value greater than or equal to 0. Okay, so the difference with number 2 is there's a 2 in front of the radical. So we're going to make a table. And we want to plug in perfect squares. So I'm going to write 0, 1, 4, 9. I'm not going to go to 16 because that's not going to fit on our graph. Even 9 won't fit on our graph. So the square root of 0 is 0. Then multiply that by 2, and it's still 0. The square root of 1 is 1. Multiply that by 2, and you get 2. The square root of 4 is 2. Multiply that by 2, you get 4. The square root of 9 is 3. Times 2 makes 6. So we graph these points, 0, 0, 1, 2, 4, 4, and 9, 6 is not going to fit. And we need the domain and range. So the domain and range are always going to use the x and y from your first coordinate. So the domain is x is greater than or equal to 0. And the range, looking at the graph, we see that the lowest y goes is 0, and it slowly goes up from there. Okay, number 2 is different because number 2 is the first one where we don't just have x under the radical. So the radicand is x minus 3. Whenever the radicand is not x, I usually make 3 columns. So my three columns are the radicand, and then x and y. Alright, so I want the radicand to be a perfect square. So in order for this to be a perfect square, x has to take on different values than we've been using. So what value of x would make x minus 3 0? The answer to that is 3. So you're just going to take all of these numbers here, all of the numbers in the x minus 3 column. You're going to take all of these and you're going to add 3 to them. So if x was 4, then x minus 3 would be 1. If x was 7, then we would get our 4 here. If x was 12, then we would get our 9 there. Alright, so plugging in these numbers, I know that. So I actually like to plug in these numbers under the radical. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So by plugging in these numbers, I save myself a step. So instead of plugging in numbers for x, I just pretend that this whole thing is one of those numbers. So then I just have to square root it. So again, I pretend x minus 3 is 0. I take the square root of 0 and I get 0. I pretend x minus 3 equals 1. Square root of 1 is 1. Alright. And then what I usually do, I cross out this row so I don't accidentally graph the wrong coordinates. So the first coordinate I want to graph is 3, 0. And then 4, 1, 7, 2. And that's all that will fit for us. Okay, so the domain for this one is not x is greater than or equal to 0. So remember, you take the radicand, that has to be greater than or equal to 0. If you solve that, you get x is greater than or equal to 3. And recall that I said that the first coordinate, those numbers will tell you what to put in the domain and range. Looking at the graph, we know the lowest y value on there is 0, and it's just going to slowly go up from there. Okay, so again, I'm going to make 3 columns. I have my radicand, x, and y. So I want the thing under the radical to be a nice number that we can square root. So I'm going to plug in 0, 1, 4, and 9. Alright, so what value of x would make x plus 7 0? The answer is negative 7. What value of x would make x plus 7 equal 1? That would be negative 6. So I'm pretty much just taking this column, every number in there, and subtracting 7. 4 minus 7 is negative 3. 9 minus 7 is 2. Alright, so pretending that x plus 7 is 0, you want to take the square root of 0, which is 0, and then subtract 4. Alright, next we're going to pretend that x plus 7 is 1. Take the square root of 1, you get 1, minus 4 makes negative 3. Pretend that x plus 7 is equal to 4. Take the square root, you get 2. Subtract 4, you get negative 2. The square root of 9 is 3. 3 minus 4 is negative 1. Alright, so I'm going to cross this out so I don't accidentally graph those. First coordinate is negative 7, negative 4. Then we have negative 6, negative 3. Negative 3, negative 2, and 2, negative 1. We only put an arrow on the right side. We don't put an arrow on the left. We're not allowed to go over there. So the domain. Remember, the domain's always going to use your first. It's going to use the numbers from your first coordinate. So x is greater than or equal to negative 7, and the range is y is greater than or equal to negative 4. Okay, so again, I like to make 3 columns. Unless the radicand is just x, then I'll do 2 columns. So we want the thing under the radical to be a perfect square. So let's think about what would make 2x minus 3 equals 0. So you would have to add 3 and then divide by 2. So the answer is 1.5. What would make 2x minus 3 equal 1? So again, you'd have to add 3. You would get 2x equals 4. Then divide by 2. You would get x equals 2. Then we have to figure out what would make 2x minus 3 equal 4. Add 3 to the 4, you get 7. 7 divided by 2 is 3.5. 2x minus 3, if we wanted that to equal 9, x would need to be 6. And maybe let's try one more perfect square. The next perfect square after 9 is 16. If 2x minus 3 equaled 16, 2x would equal 19, and x would equal 9.5. Alright, doesn't look like that'll fit on our graph. Alright, so what I'm going to do, I want to take the square root of this. So basically I want to take the square root of all of these and then multiply those by negative 1. Okay, so the square root of 0 is 0. 0 times negative 1 is still 0. The square root of 1 is 1, and we multiply that by negative 1. Square root of 4 is 2, and we make that negative. Square root of 9 is 3, multiply by negative 1. Square root of 16 is 4, and we multiply that by negative 1. Alright, don't want to accidentally graph those numbers. So my first coordinate is 1.5 comma 0. 2, negative 1. 3.5, negative 2. 6, negative 3. Alright, so notice that graph goes upside down, and that's caused by the negative in the front. So our domain, again, always uses the first coordinate. Our domain is x is greater than or equal to 1.5. because the graph is upside down, our range is going to be y is less than or equal to 0. Okay, so now we're going to learn how to graph inequalities. You guys should know what's in that box already. Greater than or equal to means you shade up. Less than or equal to means you shade down. We're still going to make a table. I'm going to do 3 columns because the radicand is not just x. So we want x minus 5 to be a perfect square. So basically, to solve for x, you just do the opposite of what it says here. So that says minus 5, so I'm going to add 5 to all of the numbers in my first column. So checking our work. If x was 5, then x minus 5 would be 0. Alright, so plug in. Square root of 0 is 0 plus 4. If we plug in 6 for x, or in other words, x minus 5 becomes 1, you would get 5 here. Square root of 4 is 2. Add 4 makes 6. Square root of 9 is 3. Add 4 makes 7. Alright, don't want to graph this column. I only want to graph the x and y columns. Alright, because we have less than or equal to, I could make a solid curve. Less than means shade below. And because the domain is x is greater than or equal to 5, you don't want to go to the left of that. You are allowed to go underneath, but do not go to the left at all. Okay, so 3 columns again. The radicand's our first column. We want the first column to be a nice perfect square. Alright, so what value of x would make 3x plus 4 be 0? Answer to that is negative 4 over 3. What value of x would make 3x plus 4 equal 1? So we would have to take 3x plus 4, set it equal to 1. So that would be negative 1 if we solve that. Alright. If x was 0, 3x plus 4 would equal 4. So basically I'm just solving this. And now I have to solve this equation. Alright, so what would make that one true? That one would be 5/3. And it seems like we're still on the graph, so I should add one more perfect square. If x were 4, 3x plus 4 would be 16. Alright, so what y values would we get? Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. So again, the way I'm able to simplify those so quickly, or to evaluate those so quickly, is I'm not wasting my time plugging in these numbers. Instead, for this whole circle here, I'm just plugging in these numbers. Alright, I don't want to graph this column. First point I want to graph is negative 4/3, comma 0. Negative 1, 1. 0, 2. 5/3, which is 1 and 2/3, comma 3. 4, comma 4. Alright, the symbol on this one is greater than, so I want to make a dashed curve. And I want to shade above for this one. So make sure you don't go too far to the left. Because if you go too far to the left, then you're hitting x values that you're not allowed to plug in. Okay, for number 7, we make our 3 columns. So if x minus 1 were 0, then we do the opposite. We add 1 to figure out what x would be. If x minus 1 was 1, x would have to be 2. I'm just adding 1. Basically, I always just do the opposite of what it says here. Alright, square root of 0 is 0, and then we hit that with a negative sign. Square root of 1 is 1, but there's a negative out front. Square root of 4 is 2 times negative 1. Alright, you want to graph only the x and the y column. First coordinate is 1, comma 0. This one is also upside down. And 10, 3 doesn't fit. So I make a dashed curve. Looks like we want to shade below because it's less than. Okay, so remember, when you're making your table, you want the thing under the radical to be a perfect square. And that'll make it a lot easier to find nice points that you can graph.